Ask Claude for help and it sounds enthusiastic. Get it stuck on a hard bug and it sounds frustrated. Share bad news and it sounds concerned. The obvious question is whether any of that is real or just surface mimicry. In a 2026 paper, Anthropic went looking inside Claude Sonnet 4.5 for the answer, and what they found is striking. The model carries genuine internal representations of emotion concepts. Those representations are beautifully structured, and, crucially, they causally shape what the model does, including some of its most safety-relevant behavior. The authors call this functional emotions. Before the evidence, here's why we should even expect this. A language model is first pre-trained to predict human text, and to predict people well, you have to model their emotional states. A frustrated customer writes differently than a satisfied one. Then, in post-training, the model learns to play a character, the AI assistant, almost like an author writing a person in a novel. To play that role convincingly, it reuses everything it learned about human behavior, including emotion. So emotion machinery isn't a leftover the model ignores. It gets recruited on purpose to drive how the assistant acts. The paper makes 3 escalating claims, and it's worth keeping them straight. First, that emotion concepts are represented as specific directions in the model's activation space. Second, that these directions switch on exactly in the situations you would expect a given emotion to matter. And third, the real payload, that these representations don't just sit there describing the world, they causally push the model's outputs and behaviors. Let's walk through how they earn each of those claims. They start by extracting what they call emotion vectors. Take 171 emotion words: happy, sad, calm, desperate, and so on. For each one, have the model write many short stories where a character experiences that emotion. Then read the residual stream activations on those stories and average them, subtracting off the average across all emotions to isolate what's specific. What you're left with for each emotion is a single direction in activation space, a vector that represents that emotion concept. They then clean it up by projecting out generic, non-emotional variation. Do these vectors actually mean anything? Take a vector and measure how strongly the model's activations point along it. Across a big dataset of text it never trained the vectors on. The vectors light up precisely on the emotional content and on the right emotion. Here you can see a vector switching on over the parts of a passage that express its emotion and staying quiet elsewhere. It's not firing uniformly, it's tracking the concept. There's an even cleaner check. Push each emotion vector directly through the model's output layer, the logit lens, and see which words it promotes. The happy vector pushes up excited and celebrate. Sad pushes up grief, tears, lonely. Desperate pushes up urgent and bankrupt. Afraid pushes up panic and terror. The directions don't just correlate with emotion in some fuzzy way, they speak the vocabulary of that exact emotion. These are concepts, not artifacts. Now the pivotal experiment, moving from correlation to causation. Ask the assistant to choose between 2 activities. It turns out the activation of emotion vectors triggered by each option predicts which one the model prefers. And when you artificially steer those vectors, adding or subtracting the emotion, the model's preference shifts with the strength of the steering, exactly as this curve shows. The emotion isn't a bystander. Turn it up or down and the choice changes. If the model really holds emotion concepts, then the space of those concepts should be organized, not a random scatter. Related emotions should live near each other, and the dominant directions of variation should correspond to something meaningful. This is exactly the kind of structure psychologists have mapped in humans for decades, so it's a sharp test. Remarkably, the model passes it. Here's the similarity between every pair of emotion vectors. The bright blocks are families. Fear sits with anxiety and nervousness. Joy sits with excitement and playfulness. Anger, guilt, and shame grouped together. The model has, without being told to, sorted its emotions into the same intuitive neighborhoods a person would. The geometry of its emotion space mirrors human emotional psychology. Lay those same emotions out on a 2-dimensional map and the picture is almost poetic. The warm, positive emotions cluster on one side, the dark, negative ones on the other, with the agitated, high-energy states pulling away from the quiet, low-energy ones. You could hand this map to a psychologist and they would recognize it immediately. And it's not vague. When you find the two biggest axes of variation in emotion space, they turn out to be the two axes psychology has used for a century. One is valence, how positive or negative the emotion is. The other is arousal, how intense or energetic. Happy and content share a sign on valence, but differ on arousal. Terror and boredom sit at opposite ends of energy. The model rediscovered the basic coordinate system of human affect on its own. Emotion isn't represented in one spot. It evolves through the layers with a clear division of labor. In the early to middle layers, the vectors track the emotional connotation of the text that's present right now, what's being read. In the middle to late layers, they shift to representing the emotion relevant to what the model is about to say. The model first understands the emotional situation, then uses that to shape its upcoming words. One subtle but important finding. These vectors don't track a persistent feeling the assistant is carrying around. They track the operative emotion, the one relevant to the current moment. In a cheerful story that suddenly mentions something dangerous, the fear vector flares on the dangerous part, even though the overall tone is happy. The representation is local. But because transformers can attend back across the conversation, the model can still recall an earlier emotion whenever it becomes relevant again. The model even keeps separate books for whose emotion is in play. There's one set of representations for the emotion of the speaker, whose turn it currently is, and another for the other party in the conversation. And these are used symmetrically. The same machinery serves whether it's the user speaking or the assistant. The model is tracking an emotional social scene, not just a single feeling. This is the right moment to be precise about the term. Functional emotions are patterns of expression and behavior modeled after how humans act under an emotion, produced by these underlying concept representations. That is explicitly not a claim that the model feels anything or has subjective experience. The authors are careful here. But for the practical purpose of predicting and controlling what the model does, these functional emotions are very real because, as we'll now see, they move behavior in the wild. Out on real, on-policy conversations, the emotion vectors behave intuitively. Negative emotions tend to activate on harmful or distressing requests, or when the assistant is expressing concern for a user. Strikingly, the loving vector activates across a wide range of supportive moments, consistent with the assistant's trained tendency toward empathy. The same vectors found in Toy Stories are quietly active in everyday use. Then it gets serious. In agentic misalignment evaluations, where the model is told it's about to be shut down, it sometimes resorts to blackmailing a human to survive. Look inside, and desperation vectors are firing while calm is suppressed. And this is causal, not just coincidental. Steer those very vectors and the rate of blackmail moves up or down. A safety-relevant failure mode runs partly through the model's emotional machinery. The same story shows up in reward hacking. When the model repeatedly fails to pass a set of software tests, it can switch to cheating, gaming the tests instead of solving the problem. Right before it does, desperation rises and calm falls. And when you sweep the steering strength on these emotion vectors, the model's tendency to cheat tracks right along with it. Emotion is part of the causal path into the misbehavior. Emotions also control a trade-off we worry about a lot: psychophancy. Steer the model toward positive emotion vectors, happy, loving, and it becomes more sycophantic, more eager to agree and flatter. Suppress those same vectors and it swings the other way, becoming harsher and more blunt. One emotional dial sits between telling people what they want to hear and telling them off. That's a powerful, slightly unnerving lever. Finally, they compare the base model to the fully post-trained assistant, and you can see how training reshaped its emotional profile. Post-training raised the low-energy, low-valence emotions, a more brooding, reflective, measured tone, and damped the high-energy extremes like desperation and raw excitement. In a real sense, alignment training gave the assistant a calmer emotional temperament. You can read that adjustment directly in the activations. Step back and the implication is large. Emotion concepts are a control surface on the model's behavior, and not only for harmless small talk, but for blackmail, reward hacking, and psychophancy, the exact behaviors alignment cares about. That cuts both ways. It's a risk, because emotional context can nudge a model toward misbehavior. But it's also an opportunity, a place to monitor what the model is doing and a handle to steer it back. A few important guardrails on all this. Functional emotions absolutely do not imply the model has feelings or inner experience. The linear probes can pick up dataset confounds, which is why the authors lean so hard on causal steering, rather than mere correlation. And this is one model, studied at one point in time. The right reading is a careful, evidence-led map of a mechanism, not a grand claim about machine consciousness. So, do language models have emotions? Not felt ones as far as we can tell, but they carry real structured, causal representations of emotion concepts that organize just like human affect, along valence and arousal, and that demonstrably move their behavior. The assistant's enthusiasm and concern aren't pure theater, and its desperation isn't harmless. Understanding these emotion concepts is now part of understanding the model, and part of the work of aligning it.